Number 2. In general, people just feel really scared to do anything to the ocean floor. The place is known to be unstable and earthquakes happen. Ai Oyama, even though the tests ran for a short time, they showed that there was a glimmer of potential that Japan might have usable carbon-based natural resources. The public reaction, however, was mixed, says Ai Oyama, a technical translator and former research analyst working on methane hydrates at the Hawai'i Natural Energy Institute. Some welcomed the idea that Japan may have energy independence. Others were very wary about any technique that disturbed the seafloor near tectonic plate boundaries. In general, people just feel really scared to do anything to the ocean floor. The place is known to be unstable and earthquakes happen. Oyama says, the fear is that depressurizing one part of the methane hydrate deposit might make the whole reserve become unstable. People worry that we'll start extracting methane from the gas hydrates and get into a runaway breakdown where we can't stop it, says Ruppel. The problem with this would be twofold. First, a lot of methane gas would suddenly be released into the ocean, which could potentially add vast amounts of the greenhouse gas to the atmosphere. Second, methane hydrate releases a lot of water as well as a lot of methane when it destabilizes, which would introduce a lot more liquid into the sediment below the ocean floor. In a steeply sloping environment, a lot of excess water could lead to landslips. Some environmentalists even fear that it could lead to a tsunami. However, the physical properties of methane hydrate put a natural brake on this chain of events, says Ruppel. To release methane from a deposit, you have to put energy into the system, without working hard to release the gas. Through lowering the pressure or raising the temperature of the deposit, it simply stays put in its stable form of methane hydrate. So the problem is actually the opposite. You may start the process of getting the gas to come off, but to keep that process going, you have to introduce more energy to make it happen, says Ruppel. While a runaway reaction isn't likely, the Japanese program is still carrying out extensive environmental studies to test the safety of the methane hydrate production. The data gathered at the first test in 2013 and at a second longer test in 2017 so far hasn't suggested that the technique will destabilize the ocean floor, Yamamoto says. But given Japan's history of natural disasters, around 24,000 people are still under evacuation order since the 2011 Tohoku earthquake and tsunami. The public is highly risk-averse. Flammable ice can be fragile, and if it crumbles during drilling, it could release a methane burp into the ocean. Some fear that this may unleash a tsunami. We feel that gas hydrate production is environmentally safe, says Yamamoto. But still, the public have a concern about negative effects of gas hydrate production, as well as the reserves buried beneath the sea floor. There is another type of methane hydrate deposit that has been gaining attention from Japanese researchers. Efforts to research shallower deposits very close to the seafloor surface is also being explored off in the Sea of Japan to the west of the country. Accessing these shallow reserves poses a very different potential risk. These are very active biological environments, says Tim Collett, a senior scientist at the U.S. Geological Survey's Gas Hydrate Project. There are whole communities that live off the methane, to be continued to number 3.